Good morning, boys. Hope you are enjoying your holidays. Okay, so spend some time to watch the videos and learn yourself. Today we will do numericals from alternating currents. Question number 7.1. Read the question. A 100 ohm resistor is connected to 220 volt 50 hertz AC supply. What is the RMS value of current in the circuit? What is the net power consumed over a full cycle? See, it is given the voltage and frequency together. That means 220 volt and 50 hertz AC supply. So the given value represents RMS voltage. Okay, when voltage and frequency given together, you should understand that it is the RMS voltage given. So what is RMS voltage? ERMS is equal to 220 volts. Then resistance also given 100 ohm. You have to find out RMS value of current. What is the equation for RMS value of current? IRMS equals ERMS by resistance. This circuit contains only a resistor. So ERMS is 220 volt divided by resistance is 100 ohm. So you are getting 2.2 ampere. This is the RMS current. Then second part of the question B, what is the net power consumed over a full cycle? Net power, you know, power in AC circuit, average power is ERMS, IRMS into cos phi. Cos phi is known as power factor. Phi is the angle between voltage and current. And we have learned when AC passes through a pure resistor, voltage and current are in phase. Therefore, phi will be 0. So what is the power? ERMS, IRMS, cos 0. Cos 0 is 1. ERMS, IRMS. So you have to multiply ERMS. What is ERMS? 220 into IRMS is 2.2. It will be 22 into 22 is equal to 484 watts. This is the power. Now question number 7.2. The peak voltage of an AC supply is 300 volt. What is the RMS voltage? So 7.2 peak voltage is given. Peak voltage means E0. E0 equals 300 volt. That is the peak volt, maximum volt. What is the RMS voltage? ERMS. Question mark. What is the equation? You know the equation for ERMS and peak voltage. RMS voltage, ERMS equals E0 by root 2. So what is E0? ERMS root 2. ERMS given as, you have to find out ERMS. E0 is given. Equals 300 divided by root 2. 300 into, you know, 1 by root 2 is 0.707. So you can just multiply and find out. You will get 212 volts. And second part of the question, RMS value of current is given 10 ampere. What is the peak current? In the same way, you have to find out peak current. But RMS current is given. What is root mean square current? RMS. IRMS equals 10 ampere. Equation RMS equals I0 by root 2. So what is I0? I0 equals IRMS root 2. What you will get? 10 root 2. 10 into 1 point, root 2 is 1.414. So 14.14 ampere. This is the peak current. Now we can do the next question, 7.3. Question number 7.3. See, read the question 7.3. A 44 millihenry inductor is connected to 220 volt to 50 hertz AC supply. So inductor, inductance is given. Inductance is denoted by L, capital L. 44 millihenry. 44 into 10 raised to minus 3 Henry. RMS voltage is given. See, voltage and frequency together, this RMS voltage. So ERMS, 220 volt. Frequency also given, frequency F, 50 hertz. You have to determine the RMS value of current in the circuit. IRMS. See, this circuit contains only an inductor. Okay. Inductor means a coil, inductor. So you know, inductive reactance, XL. What is the equation? Omega L. Inductive reactance is omega L. Omega equation is 2 pi F into L. So 2 pi into what is the frequency? 50 into L, 44 into 10 raised to minus 3. You can calculate this as 100 pi into 44 into 10 raised to minus 3. This is the inductive reactance. You need the value of RMS current. So what is the equation for RMS current? IRMS equals ERMS divided by XL. So you have to substitute the values. ERMS is given 220 volt divided by what is XL? 100 pi into 44 into 10 to the power minus 3. So you take 10 to the power minus 3 numerator, 2 into 10 raised to 3 divided by 100 pi. Okay, 44 into 4400 into pi. 44 into 100 pi. So you can cut 44 2 times, 22 1 time. So it is 10 in the numerator. Okay. Then you can simplify. You have to find the value of the current. you will get 15.9 ampere. Okay. Now we can do the next question, 7.4. A 60 microfarad capacitor is connected to a 110 volt 60 hertz AC supply. So here also RMS voltage. What is RMS voltage? 110 volt. Frequency is 60 hertz. Capacitance is 60 microfarad. Convert into farad. 60 into 10 raised to minus 6 farad. You need to find out RMS value of current in the circuit. See, this is a pure capacitive circuit. So you know the equation for capacitive reactance. Capacitive reactance XC equals 1 by omega C. Now you can find out IRMS. ERMS divided by XC. IRMS equals, what is ERMS? 110 divided by 1 by omega C. That 1 by omega C you can take in the numerator. Okay. So 1 by omega C you take in the numerator. So what you are getting? IRMS equals 110 into omega C. 110 omega, you know, 2 pi F into C. So 110 into 2 pi into 60 into, what is this capacitance? 60 into 10 raised to minus 6. You need to calculate this. On calculation, you will get 2.4 ampere. Okay. Now see the question number 7.5. In exercise 7.3 and 7.4, what is the net power absorbed by each circuit over a complete cycle? Explain your answer. You know the equation for average power in AC circuit. What is the equation? P average is equal to ERMS, IRMS, cos phi. But what is phi in an inductor? For 7.4 question, it is a pure inductor. For inductor, voltage leads the current by pi by 2. So phi is equal to pi by 2. So P average is equal to 0 because cos pi by 2 is 0. ERMS, IRMS, cos pi by 2, 0. Similarly, for capacitor, voltage lags the current by pi by 2. Again, P average will be 0 because phi is pi by 2. Okay. Now we'll do the next question. Question number 7.6. See, obtain the resonant frequency of series LCR circuit with the L inductance is given. L 2 Henry. Capacitance 32 microfarad. 32 into 10 to the power minus 6 farad. Resistance given 10 ohm. Okay. You need to find out resonant frequency. How will you find out resonant frequency? Omega R. What is the equation? Equation is 1 by root LC. Just put the values. 1 by root of what is L? 2 into 32 into 10 to the power minus 6. So it will be 1 by root of 64 into 10 raised to minus 6. And you know, root of 64 is 8. Root of 10 raised to minus 6 is 10 raised to minus 3. So you take 10 raised to minus 3 numerator, 1000 divided by 8. So that will be the angular frequency. It is 125 radians. Okay. Now, what is the second factor? What is the Q factor of this circuit? Q value. What is the equation for Q value? Q is omega L by R. Omega is 2 pi F. Angular frequency. L by R. Just put the values and find out. Omega you found out 125 into 2 divided by R. R is given as 10. So you will get 25. And quality factor has no unit. Now see the question number 7.7. A charged 30 microfarad capacitor is connected to 27 millihenry inductor. What is the angular frequency of oscillations of the circuit? See here, capacitance and inductance given. Angular frequency, same equation in the previous question. Omega R equals 1 by root LC. So 7.7, again omega equals 1 by root LC. Is equal to 1 divided by root of, what is L? 27 into 10 raised to minus 3 into C given as 30 into 10 raised to minus 6. So just you calculate it. 1 divided by root of 27 into 30 into 10 raised to minus 9. This is 810 into 10 to the power minus 9. So you write as 1 by root of 81 into 1 power minus 1 you adjust there, 10 to the power minus 8. Now you can write 1 by 9 into 10 to the power minus 4. Now 10,000 divided by 9. So that will be the answer. That much radians per second. Angular frequency unit is radians per second. So here you are getting 1.1. Okay. Then we will move to the next question. Seven point eight. We will do 7.9. 7.9. 7.8, it is not there in the syllabus. So 7.9. Okay. A series LCR circuit with the R equals to 20 ohm. L equals 1.5 Henry. Connected to a variable frequency 200 volt AC. When the frequency of the supply equals natural frequency of the circuit, what is the power transferred to the circuit in one complete cycle? See, here it is given when the frequency of supply equals natural frequency of the circuit. That means it is in resonance. In resonance, current and voltage are in phase. So we can write phi is 0. Phase angle between current and voltage is 0. You have to find out the average power. This circuit is which circuit? LCR circuit. Okay. What is the equation for average power? P average equals E RMS I RMS cos phi. So E RMS I RMS into cos 0. It is 1. Cos 0 is 1. Also, you know, when resonance, impedance of the circuit equals ohmic resistance. What is impedance? Impedance is R only here. Here ERMS is given. So we can find out IRMS. What is IRMS? ERMS divided by Z. But Z is R here. ERMS by R. Now you can find out average power. Average power put in the equation. ERMS into ERMS by R. Okay. So what you are getting ERMS? 200 is given. ERMS is given as 200. 200 into 200 divided by what is R given? R is 20. So what will be the answer? 2000 watt. That is the average power. Okay. Then we will do the question number 7.10. A radio can tune over the frequency range of portion of megawatt broadcast. See, two frequencies are given, range of frequency given. So the first frequency, lowest one, F1 is 800 kilohertz. Okay. F2 is 1200 kilohertz. Okay. LC circuit has an effective inductance. Inductance given 200 microhenry. Convert into Henry, 200 into 10 raised to minus 6. Okay. What you have to find out, what must be the range of its variable capacitor. You have to find out the capacitor range. You know the equation for frequency. Frequency, resonant frequency F is equal to 1 by 2 pi root of LC. You have to find out C1 and C2. So from this equation, if we rearrange, first you square it, you can remove the root. F square equals 1 by 4 pi square LC. From there, you can find out C. C equals 1 by 4 pi square L F square. Now you put F1 and F2 in these two equations. In this equation. So C1 will be how much? 1 by 4 pi square L F square. F1 square. So put the value F1 800 kilohertz. You can find out C1. Similarly, C2 put F2. So on putting the values, what you are getting? 1 by 4 pi square L. L is 200 into 10 raised to minus 6 into F1. What was F1? 800 kilohertz. Convert kilohertz into hertz. 800 into 10 raised to 3, the whole square. You have to simplify. Okay. So calculation, do yourself and find the answer. Similar way, we can find out C2. 1 by 4 pi square L F2 square. So just you substitute 1 by 4 pi square 200 10 raised to minus 6 into 1200 into 10 raised to 3, the whole square. Find the answer. Okay, you have to do calculation yourself. Okay. Then we will do the next question. Question number 7.11. See the question. Figure shows a series LCR circuit, right? L is given, RMS voltage is given. So ERMS given as 230 volt. L given, what is L? Inductance 5 Henry. Capacitance given, resistance given. C is 80 microfarad. What is R? 40 ohm. You have to find out the source frequency which drives the circuit in resonance. Source frequency means you need to find out the angular frequency. So omega r. What is the equation? Previous question we have done. Root of 1 by LC. Root of 1 by LC. Right? You know the values. 1 by root of, what is L? 5. C is 80, but convert microfarad into -6. So you are getting 1 divided by root of 5 into 8, 400 into 10 raised to -6. So you are getting 10 raised to -6 root 10 raised to -3. Take numerator 1000 divided by root of 400 is 20. You can cut this and you will get angular frequency as 50 radian per second. So this is the angular frequency. Question A. Okay. Then second part of the question, obtain the impedance of the circuit and amplitude of the circuit at resonant frequency. And you know, at resonance, impedance is equal to ohmic resistance. So impedance will be same as R. What is R given? 40 ohm. Now you have to find out the amplitude of current. What is amplitude of current? That is the maximum current or peak current. You have to find out I0. You know ERMS and impedance. You can find out IRMS first. What is IRMS? What is the equation? ERMS divided by Z. But Z is R here. ERMS is given as 230 divided by 40. This is IRMS. But we are asked to find out peak current. You can write IRMS as I0 by root 2. That will be 230 by 40. Right? So what is I0? 230 by 40 into root 2. See, you first calculate IRMS. IRMS value is needed for the next question. That's why just calculate IRMS. 230 divided by 40. 5.75. IRMS is 5.75. I0 will be 5.75 into root 2. That will be 8.13 ampere. So current amplitude means maximum value of current, peak value of current. Now question C. Determine the RMS potential drops across the three elements of the circuit. You have to find out RMS potential drop across the three elements of the circuit. You know, inductive reactance is XL. Capacitive reactance is XC. So, RMS potential drop across inductor I am representing as VL. What is the equation? IRMS into XL. This you have to find out. IRMS into XL. What is IRMS? 5.75. XL, you know the equation omega L. So 5.75 into omega also you determined 50, right? 50 hertz. Omega you first found out 100 by 2, right? Omega is 50 hertz. So 50 into L is given. What is L given? L is 5 Henry. So into 5. So you get 5.75 into 250. You have to calculate it. It is 1437.5 volt. Now you need to find out the RMS potential difference across capacitor. That is VC. What is the equation? Similar way, IRMS into XC. XC, you know, 1 by omega C. 1 by omega C. So IRMS is 5.75 into 1 by omega. Omega is 50. C value also given. What was the C value? C value is 80 microfarad. 80 into 10 raised to minus 6. You need to calculate it. Okay. On calculation, what you will get? 5.75 divided by 4,000 into 10 raised to minus 6. On calculation, you will get 1437.5. So we will get same, you know, at resonance, voltage across inductor and capacitance will be same. So that is why we are getting equal only, right? Then you have to find out the 3 element voltage across resistor. Voltage across the resistor, what is VR? What is the equation? I RMS into R. IRMS 5.75 into R was 40, right? R was given as 40 ohm, right? So you have to multiply. So 5.75 into 40. You will get 230 volt. Okay. Now there is one more question. Show that potential drop across LC combination is 0. So you find the potential drop across L and C. You know, VCL. Okay, that will be VC plus VL. What is VC? You found as 1437.5. VL is negative. You know, capacitor voltage is leading. Sorry, voltage is lagging the current. Inductor voltage is leading the current. So VL become negative 1437.5. So you are getting 0. So we proved that also. Okay. Okay. So children, you need to watch the video and practice these numericals by yourself. Okay. First learn the formula. I have written all the formula to you in our previous class when in school. So go through these formulas and practice.